Good morning, children. Today we are going to discuss about chemical effects of electric current. Chemical effects of electric current. So about electric current we are studying. So in the lesson electric current, electricity. So we have studied about conductors, good conductors, poor conductors and insulators. That is the property of the material through which whether the electricity can pass or not. Certain things were discussed. So here we are studying the chemical effects of electric current. So what are the chemical effects that we can produce out of this electric current? Before we see that the chemical effects, let us understand the properties of the materials and the relation with the electricity. So certain materials, they are the good conductors of electricity. In lower classes you have seen metals are good conductors of electricity. There are certain materials like wood and plastic. They are poor conductors, bad conductors of electricity. They cannot conduct. So that is the reason they are used as an insulator for electricity to protect against the electric shock. So likewise, we discussed about the conduction, the conducting nature of solids. And there we verified which solid is conducting, which solid is not conducting. How we verified? We practically verified it. We have proven that. To do so, we need to have a testing equipment, a tester, which we made ourselves. To make such a tester, you need to have a electric bulb, a small electric bulb connected to some wire. So this wire is connected to a battery. The free end of the bulb and the free end of the battery. If these two are joined together directly, the bulb glows because the circuit is completed. The electricity, it flows in the wire, electric wire, and it makes the electric bulb to glow. So this is one of the free end of the electric bulb and this is one end of the battery. If you place any object in between these 2 points, if the object is a conductor, then the circuit is completed and bulb glows. If the object is not a conductor, then the bulb doesn't glow. So by this you can test it. You can bring a nail, place the nail connecting the 2 ends. If the bulb glows, nail is a conductor. Bring a pencil, put the pencil here, the bulb doesn't glow, pencil is not a conductor. You bring some hair clip, put the hair clip here, the bulb glows, hair clip is a conductor. Put a safety pin, the bulb glows, the safety pin is a conductor. Put a matchstick here, the bulb glows, the bulb doesn't glow, the matchstick is not a conductor. So you can identify the material whether it is a conductor or not conductor based on the simple tester we made here. Simple tester. To test the conduction capacity of the material which we are testing there. Now here in this particular chapter we are going to discuss about the conductivity of liquids. Electrical conductivity in liquids. So solids we tested here in the previous classes. We have come to know what materials are the good conductors of electricity, what materials are poor conductors of electricity. Now let us discuss about whether liquids, can you test the liquids also whether the liquid is a good conductor of electricity or not? Yes, why not? We can test. But how to test that? What you need? Here also you need a tester like this, simple tester. With this you can test whether the liquid is a conductor or not. So we have taken such a simple tester to check whether liquids conduct electricity or not. The simple tester with a little modification. Here we have taken a battery, we have taken an electric bulb and the wire to complete the circuit, but this circuit is broken now. It is not connected. In the earlier case, to complete the circuit, we placed some solid objects. See that the solid objects are touching the ends of these terminals, positive and negative terminals. So when these are touching, then the electricity is conducted. The circuit is completed and electricity flows. So we did with the help of solid objects. We tested solid objects. Now we are going to test liquids. So now what to do? Here these are the free ends of the two terminals. Now we have to complete the circuit. Then take a small plastic bottle cap, small plastic bottle cap. So in that bottle cap, take some liquid, take some lemon juice or vinegar. Right? You have taken some vinegar or lemon juice in the cup and you introduced both the ends here in the cap. See that the ends are not very touching each other. See that the ends are not very far. Say 1 centimeter distance, not more than that. Now you see whether the electric bulb is glowing or not. So your electric, if this liquid is conducting, then your electric bulb should glow. Right? So before you conduct this experiment, please check whether your bulb is in correct position, the bulb is not fused out, the battery is working. How can you do that? So before you do that, just directly connect the wires. Because of the battery, the bulb glows. Yes, your circuit is working, everything is fine. The battery is fine, the bulb is fine. Now the ends are kept in a solution, that is the lemon juice or vinegar. The bulb glows. Because the vinegar or lemon juice is conducting. But here what happens, you see, sometimes the lemon juice or vinegar, even though they are conducting, they may not be able to produce that electricity, electric conduction, because their quantity is less, they are weak. So the electricity that is conducted through this liquid is not sufficient to make the bulb glow. In such cases, what to do? Sometimes the liquid we take here is a conducting liquid, but even then the bulb doesn't glow. The reason is the bulb is fine. It is in good working condition. The battery is fine. It is good. Even though the bulb doesn't glow, because the concentration of this solution, the quantity of this solution may not be sufficient to pass the electric current to the other pole, other terminal, so by that the bulb doesn't glow. In such cases, we need to make much more sensitive tester. This tester, it was used to test the solid objects, it was okay. Solids are better conductors compared to liquids. Here one point we notice, solids are better conductors of electric current compared to liquids. It is proved here because in certain cases, even though the liquid is conducting, it may not carry the electric current from one pole to another pole, so by that the bulb doesn't glow. Where is the fault? The fault is not at the bulb. The bulb is fine, it is working. The fault is not at the battery, it is fine working. The wires are properly connected, there is no fault at all. The problem is the liquid is in less quantity, not in sufficient quantity to conduct the electricity. The liquid is not in sufficient concentration to conduct the electricity, even though the liquid is conducting. In such cases, the bulb fails to glow. So here you need to have a more sensitive tester, the tester which works with a liquid even though you take a small sample of liquid, even though you take a dilute solution. So let us see how to make such a sensitive tester. So now let us see our sensitive tester. In the first case, we have taken an electric bulb. Now we replaced the electric bulb with a LED. What is LED? Light emitting diode. This is a light emitting diode. So why we have used LED in place of a electric bulb? The electric bulb, its technology is that when electric current is supplied to the electric bulb, it should produce sufficient amount of heat to make this bulb glow. The filament must be heated to bring the brightness or glow. So it requires more electricity. In case the electric supply is very weak, like in case of lemon juice or some liquid, it may not be sufficient to make the bulb glow. So even though the liquid is conducting, the bulb fails to glow. That is the reason why we replaced this electric bulb with this LED. So LED is a light emitting diode which will glow even with a very least amount of electric current. Even at very low voltage it can glow. So when you connect this, you can see this LED glowing. So by that you know whether the liquid is conducting or not. You try it with different liquids. You take some water, some distilled water, some pond water, some vinegar, some lemon juice, some other fruit or vegetable juice, tomato juice, So likewise, you take number of liquids, you test their electrical conductivity by using this sensitive tester what we made it here. So now this is the second tester that we made to test the conductivity of liquids. This is a sensitive tester compared to the first one. But even then, you are not happy with this tester also. Say here, it is used LED. It glows even with very low voltage. But even then, sometimes the solution is very weak, the solution is very less, the quantity is very less, the glow will be very less. You may not be able to identify it in a bright room. So you need some dark room to see that. So you wanted some other way of testing the conductivity. You can make one more tester, that is with the help of a compass, right? So that is a magnetic compass, you can use it. So in such cases, you can take a battery just like the previous one, a battery connected with two terminals. So one terminal is connected to an empty matchbox case. So if you have a matchbox case, empty case, you can take a matchbox empty case, and in that empty case you can keep a magnetic compass. So this is the needle. So what is this magnetic compass and how it is helpful to test whether the electric current is passing through the liquid? So when the electricity is flowing in this circuit, the needle will deflect. The deflection in the needle will show that the electricity is passing. So here the wire we are coiling around the matchbox case and it is brought down here. Now the two ends are kept in a cap or a bowl with solution. So if the electricity is conducted, it is passing, then you can see that the needle, the magnetic needle in the compass is deflected. So this deflection will indicate that the electricity is flowing and the liquid is conducting. So what liquids are conducting, what liquids are not conducting, you can make a table, collect some liquids, you make any of the tester, which one you feel comfortable. You can make either this LED tester or you can make this magnetic compass tester. Now you take milk, honey, kerosene, water, distilled water, pond water, salt water, sugar water, likewise you take different liquids. Now place the liquid in the cap and see that both the terminals are dipped in the cap in the solution. They are not very far, see that they are for 1 centimeter. Their distance must be less than 1 centimeter and see that they are not touching each other. Every time when you change the solution, just wipe out the ends, otherwise the previous solution may be there sticking to the ends. So in this way you test it and write all the results in the table. So what you will find, what kind of different things you will notice in this experiment, in this testing. Let's see. Now let us look at the conductivity of different solutions. So we learned how to make a tester to test the conductivity of a solution. So here we have taken certain solutions. One is lemon juice, the second one is pond water, third one is distilled water, fourth one is salt water. So we have taken certain liquids. The lemon juice, when it is tested with a tester to check whether it's conducting electric current or not, it will pass the test. Yes, it is a conductor. So you will notice that the lemon juice is conducting electric current. If you test the pond water, yes, it is a conductor. Now let us test with distilled water. You collected some distilled water from your science lab. It is available in the science labs. So there will be a distilled water making equipment in the science labs. Because when you are doing a chemical test, a chemical reaction, when you are mixing water with certain chemicals to make it dilute or something, the water must be free of mineral salts. Naturally, the water which we draw from the ground or from pond, the water contains natural minerals. So if those minerals are there, if those water with natural minerals is used in the laboratory, they may interact with the chemicals. That is the reason in the chemistry laboratory they use distilled water, the water which is free from natural minerals. So if you take the distilled water and test it, your tester may fail. The distilled water you have taken, it doesn't conduct electricity. So it is a poor conductor. So we can classify the materials as conductors, good conductors and poor conductors, because every material will conduct at some point based upon the condition. Most of the materials will conduct. So better you classify them as a poor conductor or a good conductor. because some materials in certain circumstances, they will act as a poor conductor, sometimes good conductor, depend upon the circumstance, condition. So better we take it is a very poor conductor. Distilled water is a poor conductor of electricity. We are talking about the liquid conductors. Lemon juice is a good liquid conductor. Pond water is a good liquid conductor. Distilled water is not a good liquid conductor. It is a poor conductor of electric current. Why? Because it doesn't contain the dissolved salts. So what we do, we add some salt to the distilled water. Take the distilled water in the cup, add some salt, stir the salt. Now you made the salt solution. Now you dip the two ends of your tester, the bulb glows. So what does it indicate? Salt water is a good conductor of electric current. So the electric conductance of liquids, it depends upon the different salts that are dissolved in that. So in general, we can, by observing all this, we can make a statement that solutions of acids, bases and salts are good conductors. Good conductors. Solutions of acids, bases and salts are good conductors of electricity rather than pure liquids, rather than plain liquids without any minerals in them. So now let us see the chemical effects of electric current, the main heading of this lesson. Now we are going to see the chemical effects of electric current. So on the liquid, we have taken a liquid, we are passing the electric current and we are going to observe what kind of chemical effects, chemical changes, the reactions that occur here. So for this you need to have a battery connected to two wires. So these two wires are connected to two electrodes. Electrodes. What are these electrodes? Where do we find them? Where do we get them? These electrodes are nothing but you can take two iron nails, some 5 to 6 centimeter, 6 centimeter and two iron nails. Otherwise, if you can get carbon rods, you can take two carbon rods. Where do you get carbon rods? You know a pencil, this is a pencil. If you break and open the pencil, inside there will be a rod connected to the steel tip. Inside there will be a rod center. Separate that rod carefully, clean it. See that you take proper care while breaking it and cleaning it. And you should not break and open all kind of batteries. Very careful. You should not try to open the batteries of electronic gadgets like tablets or mobile phones and some of the latest rechargeable electronic items. They have lithium ion batteries which are explosive. So here I am talking about battery, it is only about a pencil, Nippon or Duracell, such kind of pencils which are used in the torch and all. I am not at all talking about the batteries which are used in the cell phones, which are used in the tablets. So these kind of batteries are lithium ion batteries. They have very dangerous chemicals and they have a chance of explosion when you overheat it or try to open that. So why to go for such a risk to open to get the carbon rods when you can do your work with two iron nails? It is very simple. My option is to go with two iron nails instead of you pick up carbon rods from a pencil batteries. Of course, if it is possible, you have somebody's help, your parents' help or your brother or someone's help, then you can get carbon rod. So whatsoever, whether you take a carbon rod or two iron nails, take the two iron nails and connect the ends of these terminals of the battery, positive and negative terminals, to this iron nail. See that the connection is made on the top, the nail is immersed in the solution which you have taken. So the connections are above the level of the solution, not inside the solution. So this is how you arranged it. Okay, you fix it like this. Now it is connected, the circuit is complete. Here you have taken some solution. See that you add some salt plus some lemon drops, lemon juice drops. So you have taken some water. When you add salt and lemon juice, it will be more conducting. The conductance of this liquid increases by adding some salts. Because we discussed earlier, the salt water is more conducting than the plain water because the solids, the minerals present in the salt water help in better conduction. So some salt and lemon juice are added. Now when the reaction takes place here, you observe At the end of this rod, small bubbles are evolved. Small bubbles are evolved, and these bubbles are oxygen. This process is called as electrolysis. Electrolysis, the oxygen breaks. Where is the oxygen in the water? You know the water is H2O, 2 hydrogen and 1 oxygen. It breaks. So this is one of the effect of the electric current on a liquid. What is that effect? That is, oxygen is produced. So when you have taken here some liquid, that is that it contains the water, the hydrogen bonds break and oxygen is liberated. That is the one chemical effect. Chemical effect 1, O2 is released. Chemical effect 2, if the solution contains any metal, the metal is deposited on the electrodes. If the solution contains any metal, mineral, it will deposit on the electrodes. Metal deposition. This is the second chemical effect. If any, it depends upon the solution what you take. It depends upon the electrodes which metal you are taking. On basing that, the metal deposition takes place. The metal deposition takes place. And the third one, the color of the solution changes. The color of the solution changes. This is the third chemical effect. Actually, this lesson, the whole lesson is about these 3 points. What happens to a liquid when electricity is passed through that? Electric current is passed through that. Depending upon the metal used in the electrode, depending upon the solution we take, these 3 changes may happen. The oxygen is evolved, small bubbles of gas is evolved. Gas evolved. Metal deposition takes place on the electrodes, color of the solution changes. So these are the chemical effects of electric current. So now let us see one of the important application of chemical effects of electric current. What is that? That application is electroplating. So electroplating is a technique. It is a commercial technique which is used to apply one metal on the other metal. Say for example, you have a brass bell. You have a brass bell. You wanted to make this brass bell appear in steel look. So we wanted to give the steel look to the bell. So we have to deposit some other metal which looks like steel, but basically the material is brass. So underneath the steel deposition, the material is brass. If you see the brand new bicycle or a bike, if you see the handle, if you see the spokes of the bicycle, they look like a steel, shining. The shining is because of some metal coating. So how the metal is coated? You know how to coat with a paint. Paint is put in a sprayer, they will spray it. Then how can you spray a metal on another metal? How can you deposit a metal on another metal? So that is also, you wanted to deposit as a thin layer, not to apply as a big sheet. There is one metal, you wanted to coat it with another metal. How can you do that? So that can be achieved by a process called electroplating. So by this electroplating, they will make so many objects which have the silvery appearance, gold appearance, but actually they are not gold and silver. Some objects appear like steel, of course it is not steel. They get the look because some other metal is deposited on the base metal. Certain parts of vehicles, they have the steel look, but they are not made up of steel, they are made up of iron, they are coated by the technique called as electroplating. To understand this electroplating, we need to look at an activity experiment. So actually, what happens to the liquid and how the coating of metals takes place with the electric current. So here we have the setup. Here we have a battery and it has got 2 terminals. So this setup is connected to 2 plates. What plates they are? Copper plates. 2 copper plates of size 10 by 4 centimeter size. 2 copper plates we have taken. So before we connect the copper plates to these wires, rub the copper plates, brush them with sandpaper and wash them, dry them, wipe them completely then you fix it here. So when you rub the surface, if the surface becomes more rough, there is more chance for chemical reaction. So you can get the result quickly. So that is the reason. So you fixed the copper plates here, 10 by 4 centimeter, 2 copper plates connected to the wires, and the wires are connected to a battery. Now, the setup is kept in a beaker which contains some solution. What solution is that? Nothing but it is copper sulfate solution. How do you make copper sulfate solution? You have taken 250 ml of distilled water plus 2 spoons of copper sulfate powder. You have added to that, and dilute sulfuric acid few drops you have added. So there comes the copper sulfate solution. The copper sulfate solution, it consists of two things. One is copper, other is sulfur. So you kept the copper sulfate solution and you connected it. So the electricity, it started flowing through this liquid, this solution. So now what happens? Here the solution, it contains copper as well as sulfur. The copper sulfate, it dissociates into copper ions and sulfur ions. The copper ions, they will deposit on the negative terminal on this copper plate. These copper ions will deposit from the solution. From the solution, the copper is getting deposited on this plate, which is connected to the negative terminal. Then the liquid, the solution becomes a deficit of copper because it is getting deposited on the plate. So the copper will be less in the solution. It has to be restored. Who will give? The other plate has got the copper. It will give to the solution. So the solution will get the proper amount of copper with the sulfate. So what is happening here in a cyclic process? Here you see that the copper from this plate is passed to the liquid, to the solution, and from the solution it is passed to the another electrode. So in this way you can deposit the metal from one electrode to another electrode through a solution. So this is the chemical effect of electric current. This is one of the application. In the same way, they will take one object which is to be electroplated, and they will take another electrode as some other metal. So this is the metal A you wanted to deposit on metal B. Both are kept in an electrolytic solution. So the metal A is slowly deposited on the B through this solution. So B is coated by A. In that way, the coating is done. It is called as electroplating. So the electroplating is a technique commercially used to make the object shiny. If you want steel look, if you want silver look, if you want gold look. So all these look, it's look, not the metal. The base metal is something. You are coating some other metal on the base. It will be there for some time, some days. See, for example, any steel like electroplated mudguard, electroplated cycle parts, they will be having the shine for some time. If they are taken to salt water, if they are exposed to certain chemicals, slowly the coating will fade off, or coating will wear off, and the bottom original iron part will be exposed, or it get rusted. So that is the electroplating. Let us see what are the various objects that will be generally electroplated. Now let us see the applications of electroplating, how this electroplating is commercially used. Many of the automobile parts which are shiny appearance, the beadings either in the logo or in the front part, door handles or the light rim, certain parts of automobile vehicles and bicycles, the handles of the bicycle, the bell of the bicycle, these things are shiny metal objects. They look very shiny. So they are made shiny by electroplating. Because to make all these objects, they use iron, because iron is having good strength. But it has a dull appearance and it has a chance of getting eroded, getting rusted. So the iron is coated with chromium. Chromium is a very shiny metal. But it is not possible to make the complete part with chromium, which is expensive. And it is not having enough features to hold the strength. So it is expensive chromium. So the chromium is just plated on iron. It is coated on iron by the electroplating technique. So with less cost, you can get bright parts. And second thing is jewelry. Actually, jewelry are available in gold and platinum, silver versions. If you go to a jewelry shop, you will get silver and gold items. But there are certain fancy shops, certain shops where you find 1 gram jewelry. They call it as 1 gram gold. That means little amount of gold is coated on a big jewelry. Say for example, to make a chain or to make a necklace, if it takes some 20 grams, say to make a necklace, it may take 20 grams of gold. So it will be very expensive to make a gold item with 20 grams. They can take 20 grams an item made out of brass or some other metal, and they can coat 1 or 2 grams of gold. So gold will be plated on this jewelry by electroplating technique. It appears like a gold one. So these are the gold plated ornaments. Silver plated ornaments. You can plate silver also. So silver and gold on brass and other metals, they will coat the silver. They will coat the gold by electroplating technique. The other one, coating of tin on iron. Tin is a less reactive metal. Tin cans are used for food packing, certain food items, semi-processed food items, completely processed food items. Say if you go to market, you will find ready-made gulab jamun, ready-made rasagola. The rasagola or gulab jamun with the syrup, they are packed in a can, right? So they are packed in a metal can. So the metal can, with what it is made, the can is made up of iron, but it is coated with tin, because the tin is less reactive with the food item compared to iron. So the food is not spoiled in that. That is the reason the tin coated cans are used to store the processed food, right? So tin is coated on iron. The next one, zinc on iron. Iron is used in the construction of bridges and heavy constructions, but iron has the property of getting rusted. So to avoid that, the iron is coated with zinc by electroplating. So the electroplating, it helps us in many ways. So by that we can get the desired look of a metal with its basic features. We can get a desired good appearance look. We can deposit a costly metal on some other metal as a single thin layer with the help of a technique called as electroplating. So electroplating is one of the application of chemical effects of electric current.